Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. We are from Faculty of Mechanical Engineering and Manufacturing, Universiti Teknikal Malaysia, Melaka. Today, we want to perform our assignment 1, which is engine dynamometer. Our group consists of 4 people, which is I am Muhammad Amirul Fikri bin Muhammad Isham. Next, Muhammad Nazmi bin Nazir, Muhammad Adib Syami bin Muhammad Hailmi, and the last one, Muhammad Adam bin Zaidi. We want to present our title, which is friction type of dynamometer.
Assalamualaikum. I'm Muhammad Nazmi bin Nazir. So today I will introduce about or present about friction type of dynamometer. Okay, what is about introduction first? Okay, dynamometer cases, informally referred to as a rolling rod, is a mechanical device that uses one or more fixed roller assembled to simulate different road conditions within a controlled environment, and is used for a wide variety of vehicle testing and development purpose. There are many types of chassis dynamometer according to the target application. Okay, for example, for vehicle emission, and then for operation of onboard diagnostic, and then operation of hybrid vehicle control strategy, for noise, vibration and harness, and also for drivability testing with various driver and road profile. Okay, chassis dynamometer have been employed in the past for a squeak and rattle acceleration. Bump surface or other type road surface has been added to the chassis roll to induce various type input to excite squeak and rattles. The input are periodic rather than random because the circumference of even 10-foot diameter chassis rolls create a very short time segment. Okay, next, the history. Before about 1970, most machines were comparatively primitive rolling rod, characterized by having rollers of rather small diameter, which inadequately simulate the tire contact condition and rolling resistance experienced by the vehicle on the road. Such machines were fit with various fairly crude arrangement for applying and measuring the torque resistance, while a single fixed flywheel was commonly coupled to the roller to give an approximate simulation of a test vehicle initial mass. The diameter of the roller was increased to give more realistic traction condition, with Trunnion mount the direct current DC dynamometer with torque measurement by strain gauge, load cell, and more sophisticated control system permit more accurate simulation of road load. For our assignment is about a friction type of chassis dynamometer. The friction dynamometer operate on the principle of utilizing frictional resistance to measure mechanical power or torque. It typically consists of two components: a fixed part and a moving part. The fixed part is usually attached to a stationary frame, while the moving part is connected to the shaft or load being tested. Friction dynamometer can be further categorized into various subtypes based on their design and application, such as Prony brake dynamometer, road brake dynamometer, and eddy current dynamometer. Each subtype has its own specific configuration and utilizes frictional force in slightly different ways. Overall, friction dynamometer provide a practical and reliable means of measuring torque or power in various applications, including engine testing, industry machinery, and research laboratories.
Hi, Assalamualaikum. My name is Muhammad Shalmi, and I want to tell about the system technology diagram. Motor and engines testing dynamometer apply braking or drag resistance to motor rotations and measure the torque at the various speeds and power input levels. This device measure the output torque of motor, engines, gearbox and transmission, and the other rotary missions. A dynamometer uses an impeller to assess the power produced by a jet engine and gas turbine. Friction's dynamometer develops torque on the basis of the electromechanical principle, wherein the torque developed is independent of speed.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adam bin Zaidi. Today I will continue about friction type of dynamometer topic. Theory operation. A friction dynamometer is similarly to an eddy current dynamometer, but a fine magnetic powder is placed in the air gap between the rotor and the coil. Friction dynamometers are typically limited to lower RPM due to heat dissipation issues. A brake dynamometer applies variable load on the engine measure the engine ability to move. All RPM has related to the braking force applied. There is essentially only two types of dynamometer test procedure. Steady state only on brake dynamometer, where engine has specified RPM, or seriously of usually sequential RPMs for 3 to 5 seconds by the variable brake loading as provided by the POW or power absorber unit. Second, sweep test, inertia or brake dynamometer, where the engine is tested under load or inertia or brake loading, but allowed to sweep up RPM in a continuous fashion from specified lower starting RPM to specified end RPM.
Type of experiment on dynamometer. So, for example, if we want to measure the power of rotary engine, we will have to measure its torque as well as the angular velocity of its rotating shaft. In general, there are two categories of dynamometer: power absorptions and power transmissions. The coupling component that connects to dynamometer rotor with the driving shaft. Tachometer instrument to measure the revolution to the shaft. Housing the interact with the rotor in such a way that measurable braking torque is generated.
The advantage of this friction type, by testing the influence of change driving behavior on a chassis dynamometer, engineering can optimize the road design and traffic management for a fluent and environmentally friendly driving style. It's also the testing on chassis dynamometer is a standard process with a high accuracy, which can benefit the comparison of performance between different vehicles. Another advantage lies in the experiment with chassis dynamometer can involve the factor of climate into the experiment regardless of ambient temperature. The disadvantage of this dynamometer type of friction is as such testing cannot reflect the real-world driving condition and real-world vehicle emission. The driving condition varies each time by driving on the road, and with the development of the city and improvement of living standard, it is hard to guarantee such a circumstance can relieve the traffic congestion. Also, the driving resistance exerted to a vehicle on a chassis dynamometer is derived from the vehicle coast down test under different conditions, which cannot precisely reflect the resistance on the real world road.
Hi, I am Muhammad Amir Fikri bin Muhammad Hisham. Today, I would like to present about the improvement that can be improved on the friction type of dynamometer. In our view, some insight into the potential improvement that can be made to friction type of dynamometer in the near future based on current trend and advance in technologies. The first one is improved accuracy. This can involve refining measurement technique and reducing any source of error and variability in measurement. Advance in sensor technology and data process algorithm can contribute to more accurate and reliable torque or power measurement. Second one is increased durability. Developing more durable material and improving the design and construction of dynamometer component can increase their lifespan and reduce maintenance requirement. The third one is compact and portable design. Making it more compact, lightweight, and portable will increase its usability and flexibility. This may involve the use of advanced material, small sensor, and efficient power supply system. The fourth one is integration with IoT and data analytics. This integration can provide valuable insight into performance, efficiency, and predict maintenance, enable better process and system optimizing. The last one is compatibility with emerging powertrain technologies. Today's powertrain technology involve the development of specialized adapter and changed electrical measurement capabilities and software interface to analyze the performance of electric motor and hybrid system. That's all from me. Thank you.